Hi everyone. So today I shall talk about how to construct a model. I mean, if you have ever seen mathematical model, but you haven't ever constructed the one, it may seem like an overwhelming task. Like where to start, what's goal, what do you know whether the modeling makes sense or not. So in this video, I shall outline the typical process of modeling and give some helpful hints and suggestion to understand this overwhelming task of this large thing. I mean, to start, important piece of advice is to just start. So my Vedanta teacher, Swami Shyamanandaji, used to say this one thing that if you want to start something, just start. Don't think much about it. So start thinking about the problem and that puzzles you. I mean, grab a piece of paper and start drawing this whole diagram, illustrating like various processes, how it works at large. So obviously you'll make some mistakes. I mean, we all do. There is this telltale signs of mistakes, and that can be corrected. Over time, you'll learn more tools and techniques, and you'll allow to avoid these pitfalls, and you get to look after the more bigger picture to the truth. I mean, models can be described in biological phenomena. Even the whole philosophy of this channel is to understand this mathematical modeling and mathematical biological frame of work. And for larger picture, we shall talk about what they call this. I mean, this dynamical model. So these are very common there in biology because it provides you the original time thing, which involves how it changes. Now, within this also, we can define modeling in two forms. One is called deterministic, and another one is called your stochastic. So, deterministic, you for assumption that the future is entirely predictable. So, if your uh, life is predictable, that is deterministic. You can determine what could happen. But stochastic is more like random, stochastic events in biological systems, you see. Now, the steps for constructing stochastic models are very similar, but we postpone these for further videos. By the way, I still have to learn a bit more about it, so I'm skipping that part. Okay, now big picture. What are so there are some 7 steps of making mathematical um, modeling as per biological problems. Okay, so the very first step should be your formulate the problem, formulate the question. Now you see, so like what do you want to know exactly? Now try to describe the model in form of question. Start with simplest biological reasonable description of the problem. Okay. Now second step comes with you'll have to determine the basic ingredients. You try to determine some basic ingredients. What exactly do you need to do? I mean ingredients. Yeah. Now you try to define the variables there in what are the variables there. Describe the constraints what are there. like right to try to understand what are those interactions between variables, whether you'll treat time as discrete or continuous, like choosing time scale, how it changes, like if you are taking per second, per minute, per year, per generation, what you're taking. Try to understand what are, or define the parameters, describe if any constraints are there on the parameters. So these things are you'll have to come across. Now this third point is you'll have to qualitatively describe the biological systems. So qualitatively try to describe the biological system. So try to draw a life cycle, try to understand if it is in discrete model, how does things involve. Try to follow a diagram, you'll have to check if there's instability at some point, some random point if you plot. So yeah, many possible events can happen. Constructing a table listing outcomes, what can happen. Now, once you're done with this qualitative thing, obviously the next should be quantitative. Now, this is quantitatively try to describe your the biological system. Okay, so you're provided with these basic ingredients. Now you understand this formal question. You have some kind of qualitative thing. Now you do some kind of qualitative description of this biological system. Using the diagrams and table and as a guide, try to write down the equation. Now perform some checkpoints, like are the constraints on the variables still met as time passes. Like make sure that the unit of right hand side equals left hand side. Think whether these results can be modeled or can be addressed in the same question. So you'll have to get involved into quantitative side of it. Now fifth, I'm sorry, yeah. Now this fifth is you'll have to analyze the equation. So you are provided with, now you are having this equation. What next very obvious point would be to analyze the equation. You'll use some kind of your mathematical training now. So you'll try to simulate, you'll try to look after what are the points where they are stable or unstable. You make use of your mathematical courses. Now the sixth comes with these checks and balances. Now you'll have to check the results against the data. Now you'll have to determine how general the results are, and rather you'll have to take some alternatives to the simplest model. So you'll see if it is oversimplification of your ideas or not. Then try to extend or simplify or make some changes this thing. So you'll have to repeat this part of problem even after checking. If it is not working, you'll have to make some changes into these parts. Either it could be the case that while formulating this qualitatively thing, you'll just assume something very over assumption, I would rather call it. You oversimplified the thing which cannot be ruled out. So you'll have to get back to these again for this check and balances, when you'll have to understand what problem they have made into the system, or are they working with the data being provided. Now seventh comes your relate the result back to the question. Now you'll have to relate the results back to the question. What does that mean actually? You'll have to understand what exactly your question was, and does this equation, does this result actually validate what your original question was. Okay, so now we'll get into a bit detail part of it. So yeah, the goal. So the goal for this video is to understand these steps, which we are almost have started with. And next, we have to derive equation that actually describe the dynamics of biological phenomena. Maybe if it don't go with today's video, I shall postpone it to further ones. But yeah, we'll look after this thing. Okay, so we have to understand this thing of formulate the question. Very first point is this: we'll have to formulate the question. So okay, so we'll just try to learn how to formulate. We have to formulate the question. Let's see. So coming up with a question can be more difficult than it sounds. I mean, in most of those biological classes, students are told what the questions are and what answers have been found. Very rarely you will find a student to ask or formulate scientific questions for themselves. This is very unfortunate because in any scientific enterprise, like modeling or otherwise, the process begin with a question. I mean, one hint is to keep an eye on out for things that do not make sense or to seem to conflict. They very well might be an interesting or non-intuitive resolution. Uh, but for now, let's start with simple and don't worry about how profound your question is. Now, look around things. Try to find a living object and think up some questions about how it might change over time. How did this come up? And like some questions which are very fundamental question for model construction. So like one thing is, how does the number of branches of tree change over time? How does a like a cat change the number of mice in your yard? So that is ecological problem though. Yeah. Or like how does the number of people with flu change over the flu season? Like if it is here right now at my place it is winter. So yeah, people are getting too much cold right now. So how this changes over, how does it change over time, over the flu common cold session? Now, I mean, if you look after these examples, these are some simple toy type of example. These are very simple. One can write about equation of it. Now, these simple examples are also, they also embody many of the key elements that come together in various combination when constructing more complicated or realistic model. I mean, it is very important. I don't remember. For like, I remember there was a paper from 2000 from Bowler. What they exactly they did was very similar kind of model for immigration of describe to describe individuals moving into gay male community of San Francisco. So this flu model highlighted that some important concepts related to interaction among variables. For example, the way we model flu transmission is fundamentally very similar to the one which Phillips had done. If you remember, 1996 paper where they had talked about HIV. So, although these are very simple models, they provide excellent background for, tackling some very complex problem. So, your formulation of question is really important. I mean, takeaway point I would say key. yeah, observe the nature, because from there only you can get some simple question, but yeah, interesting question, which is important for larger thing also. Now, secondly, we have to talk about this determining the basic ingredient. I mean, this basic ingredients. What do you mean by these ingredients, though? So, I mean, once you are with the question, now we'll have to look for the step two. First, think what can change over time. So, over time, like these entities are what we call variables. I mean, everyone knows this thing. There is no rocket science. I mean, the number of branches change, number of mice there in your yard, number of population, number of people getting flu, number of these all things are variables because it changes over time. Now, what we exactly do, we give a word, a letter to these variables, be it be x, a, alpha, beta, whatever I can show it as. Okay, so this we are done. So now, to another way to avoid math error is to keep a list of these things. I mean, sometimes doing these kind of stuff can take too much toll on your head. So better it would be for you to have a table where it can represent. I mean, try to maintain a table kind of thing. So you can have some. I remember there's this one paper by Samrat Pawar, the Nature one, 2023, I guess. There he had provided a really good set of. I mean, the table was provided. Some variables were written there, and what it meant, and this part was there for some kind of description. So you can try to maintain that kind of thing. That is really important, and it helps you a lot in long run. So you don't get errors there in your mathematics. You don't run out of your variables. You don't yeah. So that is. Now, part is that you'll have to take into account this time. Now, this thing can be either continuous or it can be what they call discrete. So, I mean, discrete model assume that it change cannot compound with a time unit. For example, in discrete model for number of branches that arise during time, unit time cannot give rise to new branch. So it takes some time. So in this, usually in discrete model, it is longer time gap, while in continuous it is small at the very point of it. Okay. Now this recursion equation one can write for this kind of stuff. All well and good. Now, very important part is that you qualitatively try to understand biological truth. So you will try to understand this qualitatively description of biological processes. I mean, I guess this will take a bit technical point. So I shall rather, yes. So see you all later. Bye.